the things that we build for railway industry. And with that, welcome everybody. I will start. And we need it more than ever because it's the most climate-friendly mode of transportation that we have. But we also understand that we have a couple of challenges. In many countries, especially in Europe, we are at the maximum of our capacity, especially on main lines. We also have a situation of high delays that are too high, and extensive costs. And there's a couple of reasons for this. One is we're dealing with aging infrastructure. There's not a lot of space to build new tracks. We have a retiring workforce. So a lot of the people that had contributed to the industry and have gained a lot of knowledge will retire in the near future. And we also see that is in particular a reason for us, an underutilization of digital innovation. Connox is a company that does software and machine learning. So we're not building tracks, we're not providing a rolling stock or anything, but we're good in terms of software and analytics. And in order to help railway, we said we want to transform the railway operations for a sustainable future because of the impact of climate change. But we also know we can only achieve this together with the industry if we increase the capacity, the reliability, and the cost efficiency of railway. And so this drives our product selection. So the first question that we always ask is, does it help railway infrastructure companies? Not rolling stock, not suppliers, but really the railway infrastructure companies. Does it increase capacity, reliability, and or the cost efficiency? Does it also align with our momentum? So meaning, does it fit into our portfolio and the things we do in terms of digital solutions? And also, does it build or reinforce in our strengths? And especially when it comes to the strengths, that is what enabled us to build the products and enables us to benefit for us and for the customers in order to provide better solutions. What are our strengths? First of all, we're good at building mission critical hardware and delivering actionable insights towards our customers. That is a part that Tim, in the later part of the presentation, will especially go deeper into when it comes to our system for switches and crossings. But are the other components of our strengths, which is connected data, create great user experience, and a SaaS business model, so software as a service. And I want to introduce you to these three things as a major contribution to the railway industry and the challenges that we face. So let me start with the connected data. We see there's a lot of IoT systems out there. There's a lot of data that's been collected. But for us, it means when we deal with a system like a switch, data itself is not enough. It needs to be put in the context, into connection to its context. Like in this example here, where you see the wheel is passing from wing rail to crossing nose, and therefore it creates an impact. We measure this impact response as acceleration in g-force. And the three color dots that you see here is the same asset. It was in difference over time. And of course, in an early stage and in a stage of degradation, this asset in the blue line responds differently to different speeds than it does when it is repaired, when the crossing nose is exchanged, like in the green line. And if I want to just look at the acceleration itself, I can pick a point in time where a train is very low speed and therefore produces low acceleration. And I might say this asset is totally okay, while at a later point, even as a new exchanged crossing in there, I pick from the green line and a high speed train at high speeds, and therefore think that there's a lot of issue with this particular crossing. And so that is one of the examples of putting data really in a detailed perspective into context to understand what is actually going on. The second thing is user experience. User experience is often just associated with a user interface, but for us, it's not just this, it's really the entire life cycle of a product, from the way you order it, how you install, how you onboard someone, how they get their first value out of the system, and how the system is afterwards monitored or handled. This in particular is important because we don't want to introduce new problems, new troubles, by substituting one solution with another or one problem with another. And you see this evolution on the top. The top left picture is the drilling template that we initially had. But we learned that it's too difficult to handle. There's all kinds of mistakes in how to attach the system, the yellow box that you see below, to a sleeper. So we improved it over time to really make the installation faster and foolproof. It's so easy, in fact, that our board members can install. Literally, the picture that you see of the people, there are 4 board members from Konux in this picture. And last year in October, we went to a customer site and installed a couple of systems. And the one that you see here is actually the one that most board members participated in installing. That's why they have the signing on it. Followed by the Konux onboarding. It's important that you don't need to go through a large manual, or that you feel and understand what the system can do for you very quickly, in order to not put it aside, in order to not gain value and forget about it. And then, of course, comes what we deliver out of this. So really, this entire process, the entire life cycle of a product is thought through to make it easy to use. The last strength that I want to touch upon is our software as a service model. We're dealing a lot with machine learning, and for those kind of systems, it's key that the models can evolve, and it's key for the impact that they have for our customers. And what you see here in this picture is an asset in Germany that we initially did not pick up as a change, because it was this increase of acceleration, the thing that we measure from the wing rail crossing transition, is overlaid by a period of frost. And what we often have seen in frost periods is that the acceleration increases because the whole track bed is stiffer, but returns to a normal state after the frost period. And so, since we never had severe damage from this situation, we overlaid or discarded the increase of acceleration. The models did not pick up on this. This continued then after the frost period, quite drastically, and you can easily see this by looking at this. But for a model that is trained on, I take a certain amount of data and then predict it into the future, it looked like a normal increase until the second frost period again overlaid the condition change, the drastic condition change. And then there was the defect detected by inspection, and we learned that we have done a mistake, that our model did not pick up this defect. But the thing that we could learn from this, we could deliver and deploy an improved model within 5 days, including a full analysis of the population of another 1,400 assets, all going through multiple cycles of frost, and could ensure that we do not just pick up this in the future, but then introduce more false alert, but not actually make the model better. And so everything that you get today from Konux is the best system that we can offer today, but it will for sure be worse than tomorrow's models, than tomorrow's product. And this is enabled by our SaaS model, by distributing every learning very fast and through all of our customers. So much for the strengths. And of course, I can say a lot about what we can do good and what's right, but I also want to, before I hand over to Tim, tell you a little bit about our experience in Germany, the case study with Deutsche Bahn, which is our largest customer today. And Deutsche Bahn set out in 2017 to set up a digitalization for switches crossing monitoring, which included also integrating the data that we produce and the insights that we produce about the asset condition into their own monitoring platform, which is called Diana, and already has roughly 32,000 point machines under monitoring. We won a tender for this in 2020 originally on 650 switches to be monitored to prove that the predictions actually work. And due to the performance, Deutsche Bahn decided to increase the number of assets to 4,100 roughly in the second half of last year. And today we monitor more than 4,000 switches and crossings in one of Europe's busiest routes. During this time, Konux has proven that the predictions that we provide are correct in more than 90% of the cases. And it was done over 8 months period where Deutsche Bahn stored away our predictions. And then after the 6 months, always looked what did we predict and was it correct? And they did so over 8 months to really show that under various conditions for various assets, we are correct. With those 600, we could prove in the first half of 2023 that we can save more than 800 lost units. Lost units are an odd way to measure delayed trains. So they basically say whenever a train at a station is late by more than 90 seconds, it is lost as unit to transport, lost as track possession, and therefore they call it lost units. With this 800, we have outpaced the expected potential from Deutsche Bahn 4 times. So the savings in lost units, so basically in delayed trains, is 4 times higher than what they originally thought it would be. And this, of course, then led to a situation in which we can help Deutsche Bahn to make informed decisions on how to inspect switches and crossings, how to maintain and replace those assets. And we offer Deutsche Bahn actual insights into the current and the future condition of their infrastructure. This is a start. This is the first product. In the long run, we want to work with more data, and we want to provide some sort of brain for rail so that every Konux user is always served all relevant insights to make the best decisions. Today, we're starting with a switch. We want to go into a holistic view of switches and crossing. That's something that Tim will also mention on with the respective details. We want to grow our second product, which is all about traffic and traffic management. And then from there, combine multiple insights from various sources to provide more information, more decision-making power to our users until the state where we can automate more of the decision-making process, all fueled by the strengths that we have shown so far. And so the vision for our first product is a world where infrastructure managers like you can rely on delay-free switches at optimal costs. And with that being said, I want to hand over to Tim for the second part of the presentation.
So that was almost seamless. Thank you, Thomas. So I guess what I really want to talk about is how do you achieve that holistic approach? I guess what have we achieved so far, and what do we think the future looks like from a Konux and I guess a Network Rail perspective, as they're my sort of principal customer. Obviously, from what we've seen, the majority of switch failures can be detected, predicted, or diagnosed. And we believe that bringing multiple data sources together, so electric current, acceleration-based voiding, potentially geometry, into a single system with a single, I guess, engine, can really help achieve a step change in reliability and thus efficiency and whole life cost of these key assets. One of the things that from my time in Network Rail and since that I think is a key pain point is there's so much really high quality data, some great systems, some really mature systems, but they're not massively well integrated. There's been lots of work to sort of drive that forward and bring it together, but I still think there's huge opportunity to bring not only data source into a single place, but bring the intelligence across those data sources and really drive that predictive and diagnostic approach that I think we all want to achieve. Just some examples in here, you've got PLPR, you've obviously got our system, there's ground penetrating radar, there's the class 153s. I could go on and on. There is so much data out there, and the potential is huge. But I think if you turn it around and look at it from an end user perspective, sometimes to understand the fault, you've got to go into 7 different systems. So that's one of the things that I think as an industry we really need to challenge ourselves on and ultimately conquer, because the guys on the ground in the dark are the ones that need the information. It's not somebody sat in an office. It's the person who's got to fix something when it's gone wrong that needs that insight, and the information, I think, is there. And ultimately, I guess we want to stop them having to go out and respond. And so in terms of our product vision, really, we want to look at the holistic switch overall. So on here, we've got our Connex devices, which we fit to the bearers at the switches and crossings. They sleep whilst there's no trains. As a train comes towards them, they wake up, they record the acceleration traces from each bogey, and then go back to sleep again, because it's a key part of the device is that it's autonomous, it's battery powered, and it lasts 5 years. So we've designed, I guess, every feature around how we can maximize that battery, or it's giving the best possible insights to the customers. Every night we send the data off for processing, so the following morning you'll be able to see the asset condition from the previous day, and that will give you insights around acceleration, around voiding, around if anything has changed, if any thresholds have been passed, so on and so forth. And that's the crux of our device. As we move forward, we want to, and we have started to integrate point operating machine data. So in the UK, we're reusing existing data. And as we progress further, we want to bring in track geometry so we can understand how the train is riding on the way into the switch, and is that having an impact on the crossing life, for example. So there's a huge amount that we've achieved so far, but obviously we want to keep developing, we want to keep pushing the envelope. So in addition to our own devices, we want to leverage those multiple data sources, and we want to present it in a really simple to understand, user-friendly interface where you don't really need training to understand what the system's telling you. It's really obvious what you need to look at, where you need to go. And we do invest heavily in creating that really nice user experience, as Thomas described, not only in the office at the desk, but also out on the ground, making sure that we provide the support to the front line, we provide the support to the engineers, as well as giving them a really simple system to understand. Ultimately, we want to get to a point where we can prescribe data-backed actions for you. We aren't there yet. That is takes lots of data, it takes lots of feedback, and we need to train the algorithms. But we have made some progress, and as we get more systems in the ground and as we work with more customers, the prescription coming from the system will get better and better and better. So we should be able to tell you what ultimately what a change in acceleration most likely causes, and what the best likely treatment is, and similarly for voiding as well. Once we understand, the ballast age, so on and so forth, we can start to say don't stone blow, for example, but with data-backed insights from what's happening at the asset, as well as the inherent knowledge around the asset. And really, we want to get to this next level operational quality in managing S&C. So we do have these things tested and verified already. They're already working. They're already embedded in Network Rail and DB, and soon to be in ADIF in Spain. So we've got trackbed health, crossing health, maintenance quality. They're all things that the users have access to today, and are really working really nicely. For 2024, probably middle of this year, we want to roll out our point operating equipment on certain routes. That will be, I guess, ingesting the data from Network Rail's systems currently, reprocessing it, and giving an extra level of diagnosis and prediction that currently isn't available. And then as we go further through the year, we've also got some systems in development looking more at the actual switch health. So looking at the blade itself and understanding, is that beginning to see any kind of defects at all? And you can see that we really do want to work with our customers to integrate as much data as we can to give them the best possible outcomes. So just some, I guess, why we focus on S&C, and this graph in itself tells a picture. Obviously tells a picture of COVID as well, but the amount of failure costs from switches and crossings are increasing. And there was obviously a dip when there's less traffic, less people, so on and so forth. But I think this is extrapolated to year end. But as of P11, if you extrapolate out to 13 periods, it's looking like around 120 million from the various S&C components, which is a huge, I guess, problem and a huge opportunity as well. And I think it's one that we can really help to reduce and reduce sustainably as well, not just in the short term. The different colours on here are the different components of what Connex can do. So grey is failure modes we don't think we can find. They're not detectable with the systems that we're proposing. Green would be the point machine on its own. So this is where the point machine data is giving us insights that only relate to the swing. So nothing arising from acceleration or voiding. The orange is where it comes together really, where the holistic approach really works. So these are failure modes that would be identified either by the point machine data product, by the switch, or by a combination of both. And then the blue is failures that would be found by the switch, Connex switch only, which obviously in the crossing is where that would be the predominant number of those types of failure modes. So when we get to the switch end of the S&C, we think the devices had a lot of value in terms of prevention of delays, and I'll come on to why we think that is shortly. And then just a different view, really. So this is crossing defects over the last 4 years. I didn't have 5 years worth of data. Again, it's extrapolated to year end, but you can see there is an increase in crossing defects. Again, we've categorized it here. We've gone through all the different codes associated with crossing defects, and we believe we can find around, we've got the potential to find around 60 to 70% of them. The orange ones we don't think we can identify, and the grey ones are where the defects have arisen in, I guess, assets that are out of scope because the speed is simply too low for our products. They don't work below sort of 15 miles an hour. We are looking between 15 and 25 at the moment to make sure that we can robustly give outcomes. But at the very low speed, the accelerometer isn't able to measure the passage of the train in such a way that we can properly interrogate the data. So we sort of taken those out of scope. But obviously, you probably wouldn't necessarily invest in a lot of those locations anyway, because they're sidings, so on and so forth, and they're operated and managed differently. So where are we with Network Rail? Making some really good progress. So we've now got over 1,000 devices sold to Network Rail, and we've probably got about half of those in the track at the moment. We've had a recent upsurge, so we are pushing to get more and more devices out in the ground. And every time we put a device in, there's the potential for more insights, which creates this virtuous loop. So enables us to understand more around how the assets are performing and able to sort of predict what the future could look like. But yeah, we're now in every route. I think that there's some devices to go into Central in the very near future, and that will then have us devices live in every route. So we have got kit in every route, which is really, really good progress. And thanks to everybody that's helped us get here. In terms of what does it do? So the first thing that everybody thinks Connex is a void meter. So I'll put that up first. We are much more than just a void meter, but I thought we'd get that one on the page first of all. And really, it's continuous monitoring, void management. And we've got a really nice example here of when we've seen probably some work not go to plan. So some reballasting work was planned and done. It was only a partial reballast, so it wasn't a huge job. But you can see the impact of that work instantly had a detrimental impact on the voiding over here. That then started to increase as traffic ran over it until it was tamped, when it reduced again and they went from 50 to 80 miles an hour. So again, as soon as it went to 80 miles an hour, the asset started going off again. It went up to 125 miles an hour and then tamped it again. But still, really, it was above 4 mil, which I think is now becoming known as probably what should potentially be the threshold for voiding, particularly on a high-speed site such as this. Through the summer, they then used Connex to monitor the degradation of the asset whilst staying within the current threshold of 7 mil. And then once it got through the summer, did some interventions, but really struggled to get on top of it. So you've got a lift and pack, got a manual tamp, then there's a stone blow. And then ultimately, a lift and pat was done that did have a really positive impact on the track bed. But unfortunately, by that point, so much life had been taken out of the crossing that it cracked. So whether it was a function of fatigue plus change in stiffness, but that ended up having to be exchanged. But I think it really shows sort of the power of monitoring the asset and getting on top of this failure causing mode of displacement at the crossing. Next one, so this is where a work instruction has been put in place for network rail, utilize acceleration instead of voiding. This is what I mean about it being not just a void meter. So the acceleration can tell a huge amount about what's happening at the railhead and also what's likely to cause failures in the point machine. So here the acceleration was relatively good, so around 4 Gs. It then jumped up in May, which triggered an additional inspection. So they went out and did a full 054 inspection, and as part of that inspection, they found 10 defects. At the same time, the displacement was under 2 millimeters and still is under 2 millimeters. So there would be no trigger from voiding. There's no, I guess, response required, and there's probably very little reason to look at this asset if you're using traditional monitoring methods. But obviously, by having Connex there, they're able to see this change and were able to act on it and make sure that the asset was maintained and managed accordingly. So really positive use of acceleration there. Similar here, we predicted damage developing at the crossing. This one isn't in the UK. An on-site inspection confirmed breakouts. Well repair was prioritised and delivered. But because it was proactive, and this is really the key that we see a lot of the time, they were able to act before it failed and resulted in a speed restriction. So there was no delay minutes as a result of this. And you can see the result of the welding was really successful. Just a little bit of information, this dip here is probably due to a reduction in line speed temporarily, and we do see that a lot as well. So it's really important to understand not only what the acceleration is, but what's the speed of the trains at that point, because there is a clear link between the two, and that's another feature that we really major on. This one, squat identification on within the UK. A high-speed site, if it goes wrong there, it generally costs a lot of money. In the past, it had been caused by voiding, but they got on top of the voiding. Again, you can see here 1.5 mil voiding, so very, very good condition from that perspective. But we spotted this increase in acceleration values. The team then went out and did a detailed crossing inspection. They found 2 squats along with a poor quality weld, and you can see here where they've painted the running band white, and you can see where the train is heading through the crossing, which obviously is not a pretty picture. Ultimately, the squats were too deep to repair, so the crossing had to be replaced. But again, it was controlled. They're able to order the crossing, get it on site, get it changed before they had to put a speed restriction on. So really positive from that perspective. I will show this video, but it's you can see the sort of reverberation as the train goes through. So very little movement, but that acceleration that you can see there is obviously causing the issues. And another one. So this one, again, this is quite a high profile one. There was a speed restriction implemented following a broken crossing, and some work was done to try and maintain the track bed. So there was a manual activity and then a machine tamp. But you can see when the speed restriction was lifted, the acceleration rocketed back up. And in very short space of time, the point machine failed, and the same thing happened at another close by junction around a week later. So ultimately, we found that the acceleration is being, I guess, transferred from the track bed into the point machine and causing it to fail. And we've seen several examples of that as well. So that's why we sort of look at, again, this holistic view and bringing together point machine and switch. Being really important, and it's not just about the track elements, it's about the signal elements as well. And another high acceleration multiple points failure. So this was a switch diamond, failed 3 times in 6 months. We saw there was very high acceleration for a switch. You do see a different acceleration almost always between the switch and the crossing. The switch is almost always much lower, generally around between 1 and 2 G. This one was at 7, so real big outlier. It is a switch diamond. They do tend to have a higher acceleration than a normal switch, but even so, 7 G is very high. And ultimately, again, it was the track that was causing the issue, the rail had issues around the running band, which you can see in the picture here, and they're now planned to be resolved by welding. So ultimately, that point machine should be in much better condition in the near future. One of the new features that we've developed, so we don't just want to use force as a single point measurement, because it does really depend on the construction. It depends on the train speed, and it depends on the crossing angle as well. So the impact the impact at different locations is different. So we're trying to find a way of normalizing that. So if you've got a C switch on concrete or C switch on wood, probably a better example, we want to find what's a normal acceleration, normal force going into the asset, and therefore what are the outliers. Similarly for a H switch on concrete, that's going to have a very different signature, very different line speed, and therefore you could have 8G being healthy in one place and 6G being unhealthy in another place. So we want to be able to provide insights that point to that situation. So just by using a threshold, we think there's the strong possibility that defects will be missed. In this particular example, the asset's got very high corrected force, so that's double the population. That's indicating that there's a problem with the track. Again, the voiding is really low, 1.4 mil vertical displacement, but you've got 6 different defects within that crossing already. So we are beginning to see this correlation between acceleration, between the corrected force, and what is actually happening on the ground as well. But again, the voiding is well within the standard thresholds. Sorry, I should say 1.4 mil, not 3.4 mil here. That's a typo on my part. And so what? So how do we make this work for Network Rail? So we started working with this originated in Sussex, but we now started working with Allreach to try and understand what is a suitable threshold for action to be taken, and then what's the process for action to be taken. So in some places we've used, well, in some cases, sorry, we've used the standards, because there are some things in the standards, but with acceleration, there's nothing currently in the standards because it's so new. So we started to suggest some thresholds, and we're now working with the route engineers to refine those thresholds and also what the actions are that should be taken following a threshold being crossed. And obviously we're doing that with each route, with a view to getting either consensus or different, because obviously different operating contexts, and we're also talking with the TA as well about what that could mean. So overall, we are looking at how we can, I guess, give people an indication of what they need to do and when they need to do it. And then the final feature is maintenance quality check. So that gives us the ability for people to understand when they've done maintenance, how successful was it? So can you avoid ineffective maintenance? Can you detect unsustainable maintenance and act differently in the future? Can you avoid doing maintenance or make sure that maintenance doesn't have a detrimental impact on the asset? And then ultimately, can you just avoid doing maintenance, and can you reprioritize those resources to somewhere that needs more attention? So onto the holistic switch. So bringing in point operating equipment monitoring is a key part of our vision. So here we've got some mock-ups of what it could look like, and we are working towards releasing this in the next couple of months. But ideally, we give the customer a very clear view of what is the priority within all their assets, and then what's the priority when you drill down into a single S&C unit. So in this particular instance, the point operating equipment is shown as unhealthy, and there's an issue at a slight issue at the crossing as well. For Network Rail, again, we reuse and add value to existing data from radar, but we can also offer hardware where it's required. And this is enabling us to predict failure with confidence. So this particular instance, we started to see a change in the asset health as the weather got warmer. And over time, that health got worse and worse and worse, and it crossed the threshold that we've applied of 0.5 in around April. And there is some sort of thermal, ultimately the cause is thermal. So as the weather gets cooler, the health gets better, and as the weather gets warmer, the asset got more unhealthy. But ultimately, we were able to provide 3 months warning that this asset was going to fail before it did fail, and we got really high confidence around 6 weeks before it failed. So not only to commit the condition monitoring, the standard condition monitoring didn't have any indications on the fault. So again, the way that we're processing this data does add a new set of insights to the data that aren't currently available. So that's something that we're really looking to roll out in the near future. One thing that we've really major on is helping the users to embed the change. We have customer success team, we have solution engineers, so we've got experts in change management, but also experts in track as well. And they work really closely with the end users to make sure they understand what's happening, what the system's telling them, when we would recommend that they act. They act as a conduit between the customer and the product team to make sure that as we develop new features, they're prioritized and the product team fully understand what we're trying to achieve. And really, we are there to help hold people's hands as they get on board with the system, and then help them to become expert users as they progress with their journey with us. And that dedicated support is there. We do the training. We'll come out on site if needed, but really we want Network Rail to be self-sufficient, and that's a big goal for us. There's some videos here of the revised process that we're currently going through product acceptance with at the moment, so will enable us to drill into the bearers as opposed to gluing. And from an onboarding point of view, we work with the TMEs and whoever they recommend to make sure they get the most out of the system as quickly as possible. And we support making business cases and interrogating data to really help prove the value from installing our systems. We continually invest, so we're always looking for new features, and we are always looking at ways of measuring our success. So at the moment, we got around 55% of faults in RDMS aligned to our system, so that's a really good hit rate. And 31% of the time they've been successfully fixed. So that gives us a learning point with the end users that you've gone out, you've done some work to repair a defect, but according to the measurements from our system, that defect repair hasn't been fully successful. So it's likely to come back unless you do something different. So again, providing that loop of learning back to the end users is something that we're really keen to do. And a customer defined roadmap. So we've got some things we've done in the past, so smart alerts and threshold alerts. So telling the customer when something's changed, very important, because they haven't got the time always to dive into the system. And as we move forward, moving into data integration, so we're working with Network Rail at the moment, and in the central team in integrating our data into the core systems, and then we're looking to extend maintenance assessment, bringing in point operating equipment insights, and starting to bring in things around wheel trajectory and geometry insights as well. And all this is done in conjunction and in prioritization with the customers. And we have a working group on Thursday that with I think most routes in attendance. So that'll be really powerful in terms of making sure we're delivering what they need from us. And ultimately, we're here to help optimize capacity, increase reliability, help make you as efficient as you can be, accelerate digitalization, make data-driven decisions, and ultimately do healthier and safer work with better planning. Thank you.
Okay, thank you very much, Tim and Thomas. Let's start the Q&A session. We have several questions for the presenters. Let me find the first question to start with. So one first fair question is about a possible comparison between your system and other competitive systems. So far to date, there are several similar systems. So what are the points of strength of your particular system? I've learned that some points of strength are the fact that you provide data-driven results, the fact that you provide support for the training of the final users. Tim, what is your, what, in your opinion, what is the main point of strength of your system?
I think it's the biggest difference that we see from speaking to the customers is the insights we get from acceleration. I've spoken to multiple customers and they're sort of saying, "Oh, we're dealing with the voiding, but we're still getting asset failures." The voiding isn't always the problem, and sometimes there's no voiding at all, and there is still a problem. And that's where we really offer a point of difference from our competitors. The corrected force will drive that further, being able to provide multiple data points and use those to pinpoint the biggest outliers, the biggest problem assets, will really help prioritization as well. I think there is a lot of concern that will bring a huge amount of work to the front line if we're not careful. I think our view is that the work bank won't increase. It will just be different. It will be proactive rather than reactive. You'll be going in a planned way as opposed to a reactive way, and all the insights we offer will really help maintainers to make that change.
Okay. Then you said that you are able to understand a defect 3 months before. So, in your opinion, what is the benefit provided by your systems in terms of planning procedures for the maintenance?
I think it's twofold. Maintenance is generally delivered on a cycle. So if you're able to give a prediction of a failure and that gives you sufficient warning to fit it into the existing cycle, you aren't sending a team out twice to the same asset. So that really helps in terms of predictability, predictability of work bank. The other one is being able to, I guess, plan more effectively. Taking disruptive access is incredibly expensive. It can be incredibly disruptive. It can be very costly. So the more you can get to a point where you have a clear view of time to failure and can align that to a scheduled access window, the better you'll be. So that's the big thing for us. And ultimately, if you can find a defect earlier or a fault earlier and fix it via welding as opposed to having to change the crossing, that's hugely beneficial from a productivity and a cost perspective.
Okay, some technical information is required. So, for example, somebody is asking, Andy Moore in particular, is asking whether you have ever compared the measurements taken on a crossing equipped with and the crossing without underslipper pads. Then another question is about your monitoring system on slab tracks, for example, because so far you have spoken about only ballasted track. And then another technical question is about the geometry of the switches. So maybe to understand whether a particular geometry is less prone to defects rather than another compared to another geometry.
Okay, so I'll answer the slab one. Go on, Thomas, you go.
No, go first with the slab one.
No.
Okay.
The characteristics of slab track are such that our system isn't designed for them. So that's why it's very simple for slab track. If there's sufficient use cases, user pull, business case, then we would look at it. But at the moment, we, especially in the UK and DB, there's very little slab track to drive us to actually develop our products in that space. Go on, Thomas.
Yeah. So the question regarding undersleeper pads, we have not actively looked to compare the effect. I'm pretty sure we have assets in there that have undersleeper pads or even under rail pads. What we have learned over time is to understand what's good for an asset, when is it starting to degrading or not, and that's what we use. So we don't necessarily need to know the pads, but if we know their pads, there are no pads, we can make a comparison. That would be possible, but right now it's not in our scope as we don't see the need at this stage. We're good enough to predict the condition.
Yeah, yes, but have you ever made a comparison between undersleeper pads equipped switches and switches without undersleeper pads?
No.
No, okay.
But I mean, if there's some examples, we would be happy to look at that with Network Rail. So if somebody wants to get in contact, we can definitely do something in that space.
Okay.
Yeah.
In which countries, please?
There was another question about this. Could you use the data to look into the design that was chosen for an asset, so crossing angle and so on and so on? Yes, we do this. We actively work on this with Deutsche Bahn. They have recently introduced a specific, more precisely defined transition geometry, and they're looking at the effect for various train types and various speeds of those designs versus other designs in order to figure out what is, for an operational scenario that they expect, the best, meaning the lowest failure prone design that they can choose.
Okay. Sorry, in which countries have you so far installed your system? Germany and UK only, or other countries too?
Germany, UK, Netherlands, Belgium, Spain, Japan, China, India, Serbia, and maybe I forgot one.
Okay, thank you very much. Mohammed is asking, how do you distinguish different fleet passing which cause the peak acceleration? How do you correlate the force to the fleet? Do you use the timetable? Do you the train schedule? What kind of source do you use?
Yeah, so we use a machine learning approach that takes the acceleration trace and identifies the full spectrum of this as supervised learning from other assets. So we identify speed and train type purely based on the acceleration trace that we got. In the beginning, so meaning a couple of years ago, we used a timetable, but now once we go into new assets, we can do it without any timetable.
Okay. Some other questions? There is one last question from the author is Philip Waters. I kindly invite Philip to unmute and to ask the question directly, if you don't mind, Philip.
Thanks, Marco. So my question was around within Network Rail, on areas where you've had Conux installed, Tim, have you observed any changes in the approach to maintenance application? Typically, we've always delivered maintenance within S&C as a single discipline.
We're beginning to. I think the more mature people get with using the system, the more they're looking to maintaining it more from that system level. So Wales are really pushing ahead with that. That defect that I showed earlier was I guess an instance where the track cord and the point machine fail, and they are looking at it from a system perspective. So in Sussex, we've had lots of conversations about using the system to see when maintenance hasn't been effective, and then thinking about what different maintenance could be done to make sure you're not just going back in and doing the same maintenance, the same asset, and getting the same result. So there is quite a lot of proactive thought at the moment around how you can use the system to I guess inform you to do something differently on that asset, and then hopefully use that to change how you'd maintain other assets as well. So it's definitely moving in that direction. It's still early days, but we have got, like I said, the working group on Thursday where we'll explore that further as well.
Thanks.
Okay. An unknown user is asking, what are the existing NR systems you are exploiting data from for points monitoring?
So that's the intelligent infrastructure data, the radar data as it's known. So it's the current swing data, current time data that's currently, I guess, fitted to around 16,000 point operating equipment. But also asset data as well. That's really important. Understanding how when was the asset installed, what's its construction, so on and so forth. They're all features that are really important in building these algorithms successfully.
Any other question?
There is one around how quick the devices give information.
I missed someone. Yes, please.
Yeah, so in terms of how the system works, because the biggest battery drain is actually transferring the data from the device to the cloud for processing. So the way it works is we record a day's worth of train running, and then around probably 2 a.m. that data gets sent off for processing for presentation the next day. So there is a day lag. So if you did maintenance early in the shift, it may well show up. If you did it later in the shift, then it's going to be another day before it appears and the impact of it appears. And that's a function of the system design. I guess it's all about achieving the optimal trade-off between data usage, battery life, so on and so forth.
Okay.
You got a hand, Marco?
Yes, there is one hand up. Who wishes to speak?
Question really that I raised it basically just behind the scenes on that really is I was asking for the time because we had a tamp and it was the data was like 9 days later before we could see the improvement. So it was getting to that stage where I was worrying on sending a team back out, but the SD values that were received post repair, I would anticipate that the repair was successful, which it was. So I've looked at today's data and it's where it should be. So like I say, that was more worrying me really. We are new to this system. We've only started really using it. But I was just trying to see on that sort of delay really, what is the anticipated sort of rate of delay so we can make sure then we're not sending guys out to do something else until we know it's needed or not really. So that was all, but I can understand that.
No, that's a good point. It's a good point, Richard. So one thing that we that we're working to really improve is the change point. So we take the P90 quantile. So we take the sort of top 10% of the voiding measurements to provide the line in the asset health. But we do also provide if you drill down, you can see each individual voiding measurement on one of the plots. So if you have done some maintenance and the asset hasn't necessarily changed, you can see in a further drill down. But if you want to, we'll get in contact and give you a bit more of a demo on how that all works. But that will.
Yeah, I've got a meeting this afternoon with sorry to put in. Yeah, I've got a meeting this afternoon.
Brilliant.
Just when this popped up, I thought I'd jump on it as well, just to get some more understanding, really. But I know I've got a meeting with Gary and Matthew this afternoon.
Oh, brilliant! Thank you.
So thanks for that. Anyway, thank you, everyone.
Okay, this must be the very last question because we are at the end of the verbal time. So thank you very much. It was very interesting. So I just wish to thank you and very fascinating. It was something unknown for myself and probably also for somebody else listening to this presentation. So thank you very much again and good luck. Okay.